Okay, this is the Chapter 1 sample test, Math 12. So I'm just going to go through this test here. So this is describe the transformations in the function y equals a negative 2 x minus 1 to the third plus 3. So I'm going to go with the a, the k, the d, and the c. Okay, and we know that the a is found here, the k value is found here, the d value is found here, and the c value is found there. And so the a value is negative 1. The k value is a positive 2. The d value is negative 1. And the c value is positive 3. Okay? And so this is a negative 1 here, so it's a reflection about it's an up-down reflection, and so this would be a reflection about the x-axis. Since the k value is 2, it's a compression in the horizontal direction by 2. That's a little by 2 right there. Since it's the d value is a negative 1, it's a shift to the positive direction. That way, by 1. Since the c value is 3, it's a shift up by 3. Okay? The parent function is y equals x to the third. And a rough sketch of this graph is, well, tragically, I didn't put enough room on this, so I'm going to get some graph paper here. Okay, so if I note that my parent function is, let's see here, at negative 2, it's 8, and 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is essentially my parent function, x to the third, you know, because at 1 it's 3, or at 1 to the third is here, and 2 to the third is 8. 1 to the negative 3, or sorry, negative 1 to the third is here, and negative 2 to the third is there. Now basically I'm going to try and reflect it. So I will take each of these and reflect like so. And then this old graph is sort of removed. I'll keep it there in spirit, if you will. It's sort of there. I'm just trying to keep track of my graph here. Then the k value is compressed horizontally by 2. So that means everything gets twice as close to the y-axis there. You know, so like that. So again, I'll erase this one a little bit. Okay. Then it's a shift that way by 1 and up by 3. So I'll shift it over by 1 and up by 3. Take this one, shift it over by 1 and up by 3. Take this and shift it over by 1 and up by 3. The origin is right there. And then over by 1 and up by 3. I think that's going to do it. And there's my final product. And I'll kind of erase them as I go. Alright, and so there's the development of the graph. Next one. Given that this is the function, what is the degree? I know that the degree is 4. That's the highest lead coefficient there. It's the highest, it's the term with the highest exponent. Sorry about that. The lead coefficient is negative 12. And its end behavior. Well, since it's an even degree and a negative lead coefficient, I know that the end behavior is like that. Or you could write it from Q3 to Q4. Okay, that's number 2. Number 3, write an equation that results from the following set of transformations in the power function. X to the third. Horizontal compression by a factor of 4. We know that if we have a horizontal compression by a factor of 1/4, that means our K value must be 4. We know that if we have a reflection around the x-axis, then we must know that our A value is negative. If we must shift to the left 3 units, then our C value is negative 3. I'm going to put a 1 there since a number didn't appear. And so, since I basically am trying to get the transformations on the parent function, it's f of x is equal to A, K, x plus or minus D to the third power plus or minus C. And so I notice that my D value is actually 0 because I don't have a shift to the left or the right. And so my final function is negative 4 x to the third minus 3. Essentially it just comes down to knowing that this would transfer to that, this translates to that, this translates to that, and then if I had something about shifting to the left or right, I would translate it to that. Then I'd take all those numbers and throw them in there. If the number doesn't appear, just don't put it. I could have put plus 0 if I wanted to here. Given the following function, make a rough sketch of its graph. Oops, let me put a little f of x there. Okay, so I know that it is 5th degree, and my lead coefficient is, I got 1, 2, it's just negative here. 5th degree negative. And so, therefore, my end behavior is going to be, since it's 5th degree negative, it's going to be like this. I've got a root at negative 4, and its order is 3. And I've got a root at positive 3, and its order is 2. So this is going to be a pretty easy one to figure out. Then I'm also going to figure out the y-intercept. The y-intercept is f of 0. And so I've got a negative 0 plus 4 to the third, 0 minus 3 squared. So I'm getting a negative 4 to the third times a negative 3 squared. That's going to be a big number. So it's 4 to the third. It's 4 times 4 times, oops, 4 times 4 times 4 times a negative 3 times a negative 3. I'm just going to put 2 3's in here. Alright, so it's 4 times 4 times 4 times 3 times 3. It's negative 3 and negative 3, but it's just going to give me a positive anyway. It's 576. Alright, so there's my y-intercept. And so, y-intercept is 576, unfortunately. Big one. I've got a root at negative 4. 1, 2, 3, 4. I've got a root at 1, 2, 3. So these are my only points here. Since it's a third order root, I'm going to have to pass it doing this style. Oh, and by the way, my end behavior is again up there, and I should end up down here. Down there. So I did a little bit of a third degree, or third order going on right there. Let's see here. Let's see here. I feel like I've got some problems going on. Oh, negative 576 right there. Because of that negative sign. Right there, right there, right there. And so, I've got some problems. There we go. And so now I'm going to go down here and, hit some sort of maximum value and go through there. Then, since this positive 3 is second order, I'm going to just touch that and then go down. And this is 3, this is negative 4, and negative 576. This is basically all we're really looking for. Alright? Next one. Ooh, this one's tough. Well, it's not tough so much, but I'll probably make a mistake. So, bear with me. Basically, what I need to do is I need to subtract because I need to basically find the degree and the value of the lead coefficient. Remember then that the degree is n and the value of the lead coefficient is a, and I've got a function that says a is equal to c over n factorial. Okay, that's the equation, that I'm going to use. So my negative 69 goes here, my negative 24 goes there, my negative 3 goes there, my 6, 15, and 36. Let me get a pencil sharpener. Which I lost. Pencil sharpener. Oh, no, here it is. There we go. A little bit of sharp. Okay. So I've got a negative 24 plus 69. So 24 minus 69. It's going to give me a positive 45. Oh, look at that. It's broke. Then I've got negative 3 plus 24 is a 21. And I've got 6 plus 3 is 9. I hope I don't mess this up too much. Then I've got 15 minus 6. 15 minus 6 is 9. Got 36 minus 15 is 21. I hope. 36 minus 15. Bang. 21. 81 minus 36 is 45. Look at that. I'm already seeing that there's going to be a pattern here. Then I do minus 45, minus 21, minus 9, minus 9, minus 21. Remember, I'm doing subtracting the second differences from themselves. Okay, so this is the first differences. And then over here, sorry, I said that wrong. These are the first differences. I'm subtracting the first differences from themselves to get the second differences. 21 minus 45. 21 minus 45 is a negative 24. 9 minus 21 is a negative 12. 9 minus 9 is 0. 21 minus 9 is 12. And 45 minus 21 is 24. Okay, so these are the second differences, where these were the first differences. So then I'm going to keep going, since I don't have a constant finite difference yet. So I'm going to get a negative 24 here, negative 12, 0, and a 12. So negative 12 minus a negative 24, or negative 12 plus 24 is 12. 0 plus 12 is 12. 0 minus 12 is 12, and 24 minus 12 is 12. Bang! This is equal to C, and N is equal to 3. Right when that happens, because their third difference is achieved of same number, the C value is 12, and the N value is 3. And so, when I want to find the degree of the polynomial, it is 3. Now if I want to find the lead coefficient, it is 12 divided by 3 factorial, or 12 divided by 3 times 2 times 1, or 12 divided by 6, or 2. And so that one is done. Okay, circle any circle the following functions that are polynomials, if any. This is not, this is not, this is, and this is not. Remembering that polynomials only have whole number, natural number, exponents on the variables, the input variable. Since the input variable is x, there it is. Okay, use the following function represented to the right to find the average rate of change from 0 to 1. Well, this is 0, and this is 1. And to find the average rate of change, remember I'm basically using the slope formula for this. I'm essentially drawing a secant line right here. And then I would try and find essentially the average rate of change here. Okay, so basically what you need is 2 lines on this secant line. Okay, or 2 points on this secant line. And looking at my secant line, it looks pretty okay. So I'm actually just gonna use these points themselves actually here. So that point right there is 1, 0.75. You're just going to have to estimate as best you can. And this point is 0, negative 0.75. All right. Hopefully you can see that in there. I'll kind of zoom it in. You see those 2 points. Okay, so now in order to find the average rate of change, I've drawn my secant line already, and draw a secant line. In order to find my average rate of change, basically what I'm going to be doing is using the slope formula. So it's the change in y divided by the change in x. Right? So remember, it's delta y over delta x. My change in y here is, I'm going to have to choose, 0.75 minus a negative 0.75. And then my change in x is 1 minus 0. You have to get this right. A lot of people mess this up using, remember, if I use this as my first one, I have to use its x value here. If I use this y value as my second one, I have to use its y value here. Okay, and so I get 1.5 over 1. So my average is 1.5 y's per x. Okay, using the function represented to the right, find the instantaneous rate of change at x equals 3 and draw a tangent line at that point. Okay, so what I'm going to do is draw a tangent line at 3, and then I'm going to try and find its slope. So I'm going to try and draw the best tangent line I can. Here's 3. Oops, no, sorry. There's 3 down there, right here. Right? So I'm going to try and draw a tangent line here. It's tough to do. You just do the best you can. And I'm going to extend this tangent line as far as it'll go. So there's my tangent line. Now I have to find the slope of this tangent line, and I'm just going to use the same formula, delta y over delta x. Delta y over delta x. But I need 2 points here. So let me pick a couple of points. Let's see here. Some good points. I'm just going to pick some nice ones here as best I can. This one looks pretty good. I'm going to say that that one is 2 and 1.5. Okay? You got to do a pretty decent job picking your points, I think, on this. Let me pick another point on this line here. Let's go with this one, I suppose. It's a rough point as well. This is 1, comma. This is 1, 2, 3.6. I'll use. How's that sound? And now I'm basically just going to do the slope of this minus this over that minus that. So 3.6 minus 1.5 over 1 minus 2, giving me, 3.6 minus 1.5 is, what's that, 0.9 or something? 0.11 minus 1.5, 0.21, or 2.1. Divided by a negative 1, and so my slope is a negative 2.1 y's per x. You can kind of think of it like that. Oops, sorry. Let me say that again. It's 3.6 minus 1.5, and 1 minus 2, remembering that this makes a point, and this makes a point. Then I've got that. And if I look at it, my slope is kind of almost something like negative 2. Negative 2, positive 1. See how my slope is almost negative 2 here? Alright, so that's the first 2 pages. I'll put the next 2 pages in a different video.